I'll be talking about kind of some of the work that we've been working on at Telescope. And yeah, so I'm a data scientist at Telescope, and kind of a little bit of a background about what Telescope does is we actually are kind of a data security platform that allows our customers to kind of inventory and take kind of a global view of where any of their sensitive data or any of their secrets are located within their kind of data stores. Whether this is a structured data store, a unstructured data store, maybe it's chats in Slack or other kind of conversational data. This is kind of where we service our customers, and so that's kind of where I'm currently at. Formerly, I was a machine learning engineer at a company called Forge. Recently acquired by a company called FiscalNode, and basically doing a lot of NLP work there, working with knowledge graphs, trying to kind of create entity intelligence from open source intelligence, getting news information. Also, as everyone probably knows, it's opening day. Today, baseball is back, so thank God we made it. And in my free time, I'm a hobby potter, so just wanted to throw a couple fun things in there. Yeah, so let me kind of describe the problem in a couple kind of words here. Once we've kind of gone through the process of developing a model, which obviously there are many steps to it, but we want to kind of figure out, we want to make sure that our model is doing what we are expecting it to do. We want to make sure that we're predicting what we thought we were predicting based on our training loops, based on kind of our development cycle. We want to kind of keep track of that and kind of prevent our kind of predictions to kind of drift away from what we expect. And so why is this a problem for us at Telescope? There are many kind of ways to kind of solve this problem at a traditional company, but we're kind of given the benefit of or not the benefit, but the responsibility of classifying over customers' sensitive data. And while we would love to be able to go in and kind of spot check things, we really don't have a way of going into their actual data and checking to make sure that our classifications were correct, making sure that our actual predictions were leading to the correct kind of decision making after that. Data drift, our training data can only be so representative of what our customers actually have. And so we want to kind of make sure that our actual training data is as closely represented to the production environment data, but we'll never actually have that certainty. We won't know exactly that our data fully matches what our customers' data looks like. Same thing, it's possible that we kind of have blind spots in the training process, and so this is just another kind of additional kind of check in the cycle to make sure that we are properly kind of preparing ourselves for conversations with customers and making sure that they feel confident that our kind of predictions are gonna help them in their decision-making process. Another reason this is a problem is basically we all love like the new shiny thing. So once you've got the model ready and you think that it's great, you kind of set it and forget it. And so operationalizing this kind of quality control like loop is pretty critical in kind of making sure that your models are actually doing what you expect them to do. And finally, similar to kind of this kind of shifting desire to work on something new, it's also possible that the business priorities shift. And while this is seen as a very critical part of your business, you might not actually be able to spend the time to continue this maintenance down the line. So kind of setting that up from the beginning is pretty critical. So the usual approaches, which I said were kind of are pretty critical regardless, kind of having the quality training data that's representative of what the customer's data is going to look like, making sure you make the kind of the right architecture changes. We don't want to be working with a extremely deep model if we need some extremely low latency. We want something that actually fits the customer's needs. We don't want an analyst waiting 5 minutes for something that they need to decide on in a few seconds. So kind of making sure that the architecture is correct. Like I said, we don't have the ability to spot check the results, but this is a very valid kind of way of making sure that your model is doing what you expect it to do. If you have the ability to kind of look at that kind of customer data and you're able to exploit that. The kind of the critical thing that we at Telescope also get to take advantage of is the actual kind of customer feedback, whether that's a kind of a thumbs up if something looks good, or kind of some negative feedback, or more of like a change in the taxonomy needs to be made or something. Like this kind of customer feedback is pretty critical to to continue to improve your model. And yeah, so once you've done all that, the last thing you can do is hope for the best, and just kind of expect the best, but kind of prepare for the worst. And so at Telescope, what we want to really do is kind of minimize that last detail there. We don't want to hope for the best. We want to kind of prepare ourselves, like I said, with additional approaches. So our kind of approach, and this kind of is a combination of using work that I've done in the past with Forge, where we relied heavily on open source intelligence, and at Telescope, where we're building the model to actually identify this kind of a PII. It's typically around just named entities or other types of sensitive information. We basically go down the approach of looking for open source kind of data APIs, and so there are plenty of closed source data that you can kind of buy, but we went down the approach of trying to kind of surface a larger variety of data. And so we went and found kind of a list of APIs that were open source and kind of met our requirements when it comes to copyright use. And there's plenty of these lists on GitHub, and then maybe also even like sites that we frequently use that provide kind of this data as kind of an API, and making sure you're just kind of resembling the data that might exist in your production environment. For us, that could look like something like conversation data. Could also look at like tabular data, information that our customers might have about vendors or employees. And so basically, in this particular example, we focused on conversation data, but it just needs to resemble, in theory, what your production data is going to look like. Like I said, determine those copyright requirements. You don't want to get a nice lawsuit later because you're using the wrong type of data. And then be a good internet user. Don't kind of overwhelm a service that you really like and lose that ability. So we rely on Kaggle for some of this stuff, but there's obviously tons of other open source kind of tools that or open source data sets that you can kind of integrate into this kind of a feedback loop here. Now more kind of describing the actual architecture of what we did. The data is the first part. Now we need a kind of a way of distributing this task over time. At Telescope, we kind of do this in our development environment, and it's possible that our development environment is always shifting. Maybe it goes down because we're running migrations or updating, and so we kind of want to distribute these tasks and have kind of this kind of fail protection. And so we kind of relied heavily on the Celery task queue. So anyone here used Celery before? It's a pretty commonly used library, and basically just a ton of great kind of features for this particular work. Creating the cron jobs, I think, allows you to have a very regular kind of either data pulling or classification, which I'll describe in the next slide. But yeah, it also has tons of connectors to existing queue systems, and then additionally, it allows you to persist that data to a database so that you can kind of continue the analysis beyond just running this kind of end-to-end test, basically. So with Celery, we basically go and we fetch the data from the APIs that we've selected that fit our model. It might also be useful for you to just select random data too, because you want to see what your model might do with random data, because sometimes that kind of testing is important to see these edge cases. But for us, we kind of focused on like the data that resembles our production environment. And then we kind of, like I said, using the kind of the configuration, you can control the volume of data that's getting pulled and the amount of data that's getting pushed onto these queues. From those queues, you can then run the classifications through your entire system. So we provide our customers basically with a API that allows you to scan or scrub. The scan or the classify endpoint basically tells you what entities existed in that context, and then the scrub will redact it so that if there is any PII or any PHI, it is eliminated from the underlying text. And then, so we'll run those classifications, and then, like I said, it'll persist that in the database. So we'll have kind of like a running history of maybe the last month or the last 2 months of these classifications, which is pretty essential for some of these kind of later tasks like regression testing or just performance and reporting. Like maybe the customer wants to know exactly how we perform on a particular government passport or like a particular like PII element. So just a quick kind of like graph here of like what I've described, and so you can kind of see we start with like the data. You go to the task queue once we've pulled the data off of the result. Then we run through the classification model. In our case, it could be whatever model you have within your pipeline. Put the result back on the task queue, and then you persist those results on the database. So at this point, we have kind of this this data set that is great, but it doesn't actually have any kind of validation or any information about how well you're doing or how well your performance is doing. So once we have like all this data, we can actually go through and kind of go through a very similar loop that we would do if we were doing a training, basically. So one of the kind of the annotation shops that we've used at Telescope is Scale.AI, but we also do some internal kind of review. And so we basically exploit the kind of the configuration where it allows you to kind of pick how many annotators you want, what kind of inner annotator agreement you want, if there's any kind of review beyond that you need, and then you can kind of send those over over their API. Additionally, we've used an open source tool called Docano, which I really recommend if you ever need to do any kind of. They do a ton of different types of annotation, but we use it for natural language, obviously. But it could also be something like image segmentation and additional tools. It's open source, and you can host it yourself, and it's great. I recommend it. But yeah, so we basically go and we go on a weekly kind of basis. We pull off some results, a subset of the results that we had generated over the past week. We send over those to Scale. Obviously, if you want to do that internal annotation, you can do that yourself as well and send it to Docano. They expose an API, and then those results get persisted in an additional database. So with these kind of results, we can kind of compute a handful of different metrics which are important for stakeholders, important to kind of to share with customers during that kind of that acquisition process when they're trying to kind of decide between vendors. We can also give them a much more fine-grained kind of description of our results. And then we can do this kind of regression testing where if we have a new model that we're working on deploying, we want to make sure that the changes are positive changes. We want to make sure that we're not kind of changing the whole system and kind of breaking some of the previous classification. So basically, comparison of previous models. And then the kind of the kicker here is that we also get this additional training data for future kind of model improvements. Maybe down the line we want to move to a smaller kind of model that doesn't rely as much on the pre-trained model or something. It's possible that we have a lower compute envelope or a smaller compute envelope that we need to fit. And so in those situations, we might need a larger training set to kind of get a similar amount of results. And so having this additional training data is kind of essential for us. So just kind of an overview here. Some of the kind of the processes that we have downstream are kind of generating these kind of F1 recall split graphs and basically creating a dashboard around it. So we'll create this dashboard so we can have kind of a pretty regularly updated idea of how our performance is for our customers. And then we use these findings to kind of determine if we're going to need to get additional data from different sources, or if we're doing pretty good according to our kind of our external kind of test set here. So I'll wrap up with some final thoughts here. As you kind of expect, the usual approaches are still extremely important. Even this augmented data set is not going to be always 100% consistent with the data that your customer has. So you still have to kind of rely on these usual approaches, which in our case, like I said, customer feedback, you really need to kind of take advantage of an engaged customer. If they're giving you a signal in a certain way, it's pretty critical that you listen to them there. The initial training set and the annotation guide, I mean, as with any kind of a supervised task, that is a pretty kind of foundational part. The visibility here is key. If our customers want to know, if our stakeholders internally want to know what our performance looks like, it needs to be an easy task for them to go like into a Grafana dashboard or something and quickly pull that off. And we've definitely had some initial success at Telescope kind of having to roll back regressions before they make it to the customers is always nicer than having to do it after. And so making sure we catch those kind of those really weird edge cases beforehand has been really helpful. But yeah, that's it. Thanks for listening.